Right. So let's get started then. Basically, let's start with the first question then. So the first question was two vessels. So basically, what the question says that you have two vessels with water. The first vessel is a gram of water, and the second vessel is b gram of water. Right now, both the vessels are very large and they can hold any amount of water. Now they are saying that you have another cup which can hold up to c gram of water, and in one move, what you can do is you can remove up to c gram of water from any one vessel, right, and pour it into the another vessel. Now they are saying that how many minimum number of moves are required so as to make the mass of same, right? So this is basically the question. So what they basically are saying is, let's say you have A, you have B, and you can let's assume A is less than B. Let's take an example. Let's say this is 3, and let's say this is 7. Now let's say if let's say take C equal to 2. So what it is saying is, it is saying you can remove at max 2 from B, and you need to tell the minimum number of moves to make A equal to B. So what basically what we need to do is, we will definitely choose the one which has the maximum more weight, right? More water, right? Because the only operation which we can do is removing it part, right? So let's say if the C is 2, so what I will do is I will remove 2. I will remove 2 from here. So it will become 5, and I will add this 2 here, right? So this will also become 5, right? So the number of operation required here is equal to 1, right? But let's say if it was 3 and 11, right? In that case, if I remove 2 from here, it will become 9, and this will become 5, right? Then again, if I remove 2 from here, it will become 7, and this will become 7, right? So let's take one more example. Let's say if this is 3 and this is 13. So if I remove 2 from here, it will become so it will become 11, and this will become 5, right? Now please mute yourself. Okay, so we were at 13 to 11, then 5, it will become 5, then this will become 9, and this will become 7, right? Okay. Now, in one more step, what you could do is, we know that if I remove 2 from here, then this will become 7 and this will become 9, right? So why will we do that? We will just remove 1 from here, and we will add 1 here, right? So this will also become 8, and this will also become 8. So basically what we are doing is, you are seeing this C as a, you can remove C, but exactly what is happening is you can remove C from here and you can add C there, right? So basically you are, in one operation, you are removing the difference of 2 times C, right? Or you can say you are removing in each step, so you are removing 2 times. So what I did was, let's say if we had 3 and we had 11, so what I did was, let's find their difference. So their difference is 8, right? So either you can do it 2 times C, or what I can do is, like, I will just say that the difference is 2. Difference is 4, right? I will just divide it by 2, because if you remove half and you add to the another part, it's same as just removing the half difference, right? So I took the difference as 4. Then what I did was, now we have 4, and in each move you are removing C, right? So the number of steps will be required would be 4 by C plus, let's say if here C was equal to 2, so it got divided exactly, right? That's why we got 2. But let's say if the difference was 5, in that case, if you do by 2, in that case, what you will need is, you will need one more time, right? Because 5 by 2 is 2.5, right? So 2.5 moves does not make any sense, right? So it will be rounded off to the greater element, which is equal to 3. Any doubt? You can unmute yourself. Anyone has doubt?
Can you explain that you said like 2C term, like I don't know. 2C.
Okay, what I was saying is, let's say you have 3 and you have 11, right?
Mm.
So if we take C equal to 2, so in one move, what you are doing is you are removing -2 here and you are adding +2 here, right? So initial difference was 8, right? After this move, this will become 5 and this will become 9, right? So what is the difference now? This is 4, right? So actually, what you did was you removed 2 from one side and you added 2 to the other side. You removed 2 from the bigger element and you added 2 to the small element. So what basically it did was it reduced the distance by 2c, right? So that's why what I did was I just told, okay, then in each move you are dividing it by 2c, right? You are reducing the difference by 2c. So let's take the difference by 2 only, right? So instead of solving for 8 as a difference, I am saying that let's solve for 4 and that will do the work. This is what I'm saying. Hope you understood the question or the approach. Please just tell me yes or no. I guess we understood. Any other doubt? Like anyone clear? Okay. Please unmute yourself and just tell me. So it will be much better. So let's go to the coding part then. So in the coding part, what we basically did was I took ABS of A minus B. Why? I took ABS. It was because I didn't want to go find the maximum element, then the minimum element, and then divide by that, right? So that's why I just took ABS of A minus B. So this will directly give me maximum element minus minimum element, right? And I have added +1 there, right? Because let's say if the difference is 7, so 7 by 2 will be 3.5, right? But 3.5 does not make any sense, right? Because each time you will be removing. So I have added values of 3.5, it just becomes 4. And similarly, as I told you, let's say if we have 7 and we divide by 2. So in that, or as I told you, that let's say we have 7 as the difference, right? Let's say we have 7 as the difference, and let's say C is equal to 3. So what I am saying is, let's write 7 by 3 plus if remainder is not equal to 0, then we will add 1 there, right? So instead of writing it directly, what I did was I write 7 plus 3 minus 1 by 3. So this will actually give me 3 only. But let's say if this was 9 and C equal to 3. So in that case, 9 plus 3 minus 1 by 3, it will also give me 3. So this is a basic tactic which we use if we want to add let's say if we want 1, if the remainder is not equal to 0, in that case what we do is we just add this C minus 1 and this helps us. And that's just in the end I just written the answer. Is the approach clear to all? Can we directly use ceil function? Yeah, you can use it. Why did you divide by 2? Can you explain at the last part? Okay. Yeah, okay. Why I divided this by 2 is basically, I will explain again. What I am saying is, like, let's say if you have 3 and you have 7. So in one step, what you are doing is you are removing C from the larger element and you are adding C to the smaller element, right? So it's like you are not solving for C, you are actually solving for 2C. So that's why what I told you is either so it's similar to solving 4 difference or 2 difference, right? That's why we took 2 as a difference. Is it clear now? Just take a few example and you will understand that actually what you are doing is you are not doing it by C, it is you are actually doing it by 2C. That's why we took it. Is it clear now? Okay. Let's move to the second question then. Okay. So basically, what the question is saying is that we have a corridor which extends to infinity, right? Now you are at room 1 and you need to move to the room K and then return back to room 1, and you choose the value of K, and you start from 1 and then you move to K and then you come back, right? And moving from one cell to the adjacent cell takes 1 second, right? Now the question is saying that there exist n traps and the ith trap is located at room Di, and it will be activated SI seconds after you enter the room Di. Once a trap is activated, you cannot enter or exit a room, and we need to maximize the value of K. So I will explain the question in a better manner. What it is saying is there are infinite cells, right? There are infinite cells, let's say, right? Let's call this cell 1, 2, 3, 4, 5, 6, 7, 8. It is saying that some cells have some trap. So let's say this cell has a trap. Let's say this cell also has a trap. And let's say trap value is 2. Or what you can say, the value of SI is 2 here. Let's say the SI value of SI is, let's say, 1 here. And let's say this has 3, right? So the value of SI is 3. Now what the question is saying, you have to choose a value of K and you will move from 1 to K and then come back, right? Now you need to maximize K such that you do not fall into any trap. And what do you mean by trap is, so at 3 index, we have a value of 2, right? So what it basically says, if you come here after 5, from 5 or after 5, then you will never be able to go back to 1, right? So after 5 seconds, you can't come here, right? So similarly, this is saying that after 7 seconds, pardon. Basically, what it is saying is, let's say if you reach at time X here, so for the first time, then it is saying that after X plus 2, if you come, then you will get trapped. Similarly, let's say if you reach at time Y here, so it is saying that after reaching Y, after time Y plus 1, you cannot come here. Let's say if you reach Z here for the first time, then you cannot pass after Z plus 3 from here. The question is saying this. So based on that, we need to do some maths and we need to find the solution. So basically, if we look at this example once more, now let's say you decided, let's take those values back. This was 2, this was 1, 2, 3, 4, 5, 6, 7, 8. Right, now this is 2, this is 1, and this is 3. So what the question is saying, let's say if I decide to take K as this, let's say I decided to take K as 8. Now, in that case, what will happen is, I will reach 1. Right, I start from 1, so I will reach here at 1 second, then I will reach here at 2 seconds, then I will reach here at 3 seconds, 4, 5, 6, 7 seconds, right? Then I will start moving back, right? So I will reach here at 8 seconds, then 9 seconds, then 10 seconds, then 11, 12, 13, 12, 13, and 14 seconds, right? Now you reached here at 6, right? Now the question is, let me check if it is saying strictly or not. Then we'll move. And will be activated after you enter the room DI. Okay. So strictly, it is saying strictly. So what the question is saying, you entered at 7 for the first time at 6, right? So now you cannot enter back after 9 or on 9. So here we have reached at 8, right? So it's okay. But the trap will get activated at 9. What? 6 plus 3. The trap will get activated at 9, and you won't be able to move from this place from 9 itself. Similarly, what this is saying is you reached 6 for the first time at 5, right? And now what it is saying is you can't go from here after 6, right? So you reached here at 9, right? So this will, you will get trapped, right? Because the trap will get activated from 6. Similarly, you started at 2, right? You reached for the first time at 2. So you cannot go after 4 from here, right? From or after 4, right? So this is what the question is saying. So we can't choose k as equal to 8 here, right? So then we need to choose some smaller k, right? So what basically I'm saying is, let's try to find the solution, like what we can do for this question. So what basically I'm saying is, like, let's say this is 1, 2, 3, 4, 5, 6, 7. So basically what I'm saying is, let's say this is this moves ahead and ahead and you say this is your k. So this will be k minus 1, this will be k minus 2, right? So for the first time when you will reach a particular, so you will reach this 7 at what time? For the first time at 6, right? Because you will reach here at 1, then here at 2, then here at 3, then here at 4, then here at 5, 6. Similarly at k you will reach at k minus 1 time, right? So for the first time you are reaching the ith cell at I minus 1 time, right? So you are reaching the ith cell at time I minus 1. Similarly, when you will be reaching for the second time, let's say if I want to compute for this guy, let's say I want to compute for k minus 1. Then since I reached k for the first time at k minus 1, here I reached at k minus 1. So I will reach here at k, right? Again, then k plus 1, then k plus 2, right? So if a cell is at a distance of 1 from k, then it will take k minus 1 plus 1 time, right? Similarly, this cell is at a 2 distance from k, right? Or let's write it here then. What I'm saying is, you reached this k cell at time k minus 1, right? Now you start the backward journey. So this is at distance 1, right? So you will reach here at k. Now this is at distance total 2. So you will reach here at k plus 1. Similarly, this is at distance 3, right? So you will reach at k plus 2, right? So, and what would be the distance? So let's say this is index I, right? So this distance would be actually k minus I, right? And if we see this formula, the cell at distance 2 is reaching at k plus 1 time, right? The cell at distance 3 is reaching at k plus 2 time, right? So similarly, the cell at ith index or k minus I distance will reach at, this is the distance, right? So if at distance 3, it is reaching at k plus 2. So this distance will reach at this time, right? So we got for the first time at I minus 1, for the second time at k minus I minus 1, right? So these two are the time at which we reach a particular cell. Now what we want is, so suppose you reached at I minus 1 time for the first, right? So in that case, if we add SI to it, so this is the time before which you should leave this trap, right? So this time, so when we reach the second time, that second time should be less than this k, should be less than this I minus 1 plus SI, right? So from here, what we got is k should be less than I minus 1 plus s of I minus k plus I minus 1, right? Sorry, plus 1. So this one and this one will get cancelled, and uh, and you will be left with 2I plus s of I should be greater than k. So for each index, we got a condition that what should be the particular condition, and we need to find. So for a particular index I, we got that if 2 of I plus s of I is greater than k, in that case, you will be able to pass through I without getting trapped. So we will get a value of k for each and every index, right? And then we will need to find the minimum k, right? Because we want to maximize the k, but the k, whatever k you will get, should follow all the conditions, right? So we will just find the minimum one, and that would be the answer among all those. Okay. Is the approach clear to you? Yeah, I think this question is little bit difficult for B type of question. Hello. Okay. So yeah, so basically, this was the formula which we were getting. 2 of I plus s of I is greater than k. So uh, so so basically, and this is strictly right. So k will be equal then k. So if we want a value of k, then for this condition, you will have a value of 2 of I plus s of I minus 1, right? So k belongs from here to here, right? We will just have to check for each and every one. So we did similar thing, just a small one line code for this question. Uh, right, we just check that condition. Uh, right, this is the index, right? Because they were saying that if the type is at ith index, then jth index, then they are giving the indexes, right? So 2 times index plus s of I. And this is the, and because I think there was 2k here, right? S of I plus k minus 1 second time. I think we missed something here. Yes. So we solved it here. We found the answer. And yeah. So we are taking the minimum of all of those, right? I think why we are getting divided by 2, I missed something. Let me take one. Let's think for one again. We are reaching at I minus index for the first time, and we are reaching k minus I minus 1 for the second time, right? So let's say if the index is I minus 1, then I minus 1 should be greater than s of I plus k minus I, right? So k should be less than 2 of I plus s of I. This seems to be correct. I'm not getting where I'm missing it.
So because we are coming back again, that's why.
Okay. Sorry. Yeah, you are saying right, because we are coming back. That's why it should be 2 times. Okay, got it. Okay, yeah. So we took divide by 2 there, and that's why we are just taking the minimum of all of these, and we are just taking the answer, right? Now let's. Is this question clear to all of you? Okay. Why minimum? Okay. Why we are taking minimum is that we found a condition, right? That 2 of I plus s of I divided by 2, right? This should be greater than k, right? So let's say for index I equal to 2, we found this value equal to, let's say, 3. For, let's say, index equal to 4, we found this value equal to 5. Let's say for index equal to 6, we found this value as 4, right? So what we got was this should be greater than k, this should be greater than k, this should be greater than k, right? 3 should be greater than k, 5 should be greater than k, 4 should be greater than k. From this, what we can have the value of k as from 0 to 2, right? And from this, we can have value of k as 0 to 4, right? From this, we can have value of k from 0 to 3, right? So it is saying that your k should belong to 0 to 2. It is saying it should belong to 0 to 4, and it is saying it should belong to 0 to 3, right? So we need to take the intersection of all those, right? So the intersection will be this two, right? That's why we are taking minimum, right? Because the case should follow all the conditions, right? That's why. I hope it is clear now. Okay, got it. Let's start with the question number 3 then. Okay. Now the question is saying you are given two integers L and R such that L is less than equal to R, and we need to find positive integer a comma b such that L is less than equal to a plus b R, and the GCD is not equal to 1, right? So basically what the question is saying, you are given L less than equal to R, we need to find two integers a and b such that the GCD of a comma b should not be equal to 1, means they should have some factor common, right? Similarly, what it is saying is the sum of a plus b should lie in this range, right? So we need to find. So what I told is, let's assume that the GCD of a comma b is equal to k, right? Now, if the GCD of a comma b is equal to k, so we can write a equal to a dash k, right? And similarly, we can write b equal to b dash k, right? Because since the GCD is equal to k, so k is a divisor of both a and b, right? Now, what I'm saying is, so what now we want is the sum of a plus b should be less than equal to r, right? So from there, what we can get is uh, a dash k plus b dash k should be less than equal to r, right? So now L has to be less than a dash plus b dash k less than equal to r, right? So from here, we can get L should be hello. Am I audible to all now?
Yes.
Okay. So till where have you understood? Is this part clear to all, or was there a lag here? Is this part clear to all, or was there a lag here? Okay, it was that. Yes. Okay. So we were here, right? So now we need to find a k which satisfies this condition, right? So basically, what we can do is now we want to find a k, right? And we want to maximize its range as much as possible, right? Because yeah, so we want various options, right? So basically, what I did was I thought what could be the minimum value of this a dash plus b dash, right? Because if I want to maximize this range, I wanted this should be as minimum as possible, right? So and so that's why what basically I want to maximize the range, right? But now what could be the minimum possible value of this, right? A dash plus b dash. So if we think like, let's say if we take those two elements as equal, in that case, a dash and equal to b dash equal to 1. In that case, this L by 2 will, this is the minimum possible value you can get, right? Of because let's say if I take a dash equal to 1 and let's say I take b dash equal to 2, in that case this value will become equal to 3, right? So that will become L by 3, right? Now so basically what I'm saying mean is this part, this is the max minimum, this is the like this is the what you can say, if we take L by 3, so we are reducing our case range, right? That's why what I'm saying is you should take L by 2, right? So k can be greater than equal to k greater than equal to L by 2, right? Similarly, what I am doing here is I am also saying let's this R upon a dash plus b dash, right? Now this part also, this a dash plus b dash, this can also be by 2, right? So this can also range from R by 2 to, let's say, R by R only, right? You can go from there to, right? So if I want only 1k, if I want just a 1k, what I can do is if I decide to take a dash equal to 1 and b dash equal to 1, in that case I can get a solution, right? If I choose to take k and k here, right? That can help me. So basically what I'm saying is
Hello.
we can
Hello.
yes.
Yeah, can you explain from there, like
Hello.
a dash is equal to b dash is to 1? Can you
Yeah.
can you explain from there
Can you
where a
please?
dash
Yeah,
equals to b
I will
dash?
explain again.
Yeah.
Yeah, I will explain once again. Please. Yeah. So what I'm saying is I want to find the range, right? Now we got a condition that I upon plus b dash is less than equal to k, less than equal to uh, r upon a dash plus b dash, right? So we wanted to find a value of k, right? So I decided like what could be the range of this value, right? So if we wanted to find the range of this value, what we basically did was, let's take an example. Let's say, and that will be clear better. So let's say we have 11 and 15, right? So if we have 11 and 15, right? Now what I'm saying is, let's say if you, so this will, the minimum possible value of a dash plus b dash is equal to 2, right? A dash plus b dash is equal to 2 if you take this as also 1 and this is also 1. So what I'm saying is, so if we divide 11 by 2, we will get 5, right? But we will have to take the max of it, right? The seal of it, right? So in that case, we will be having 6, right? So I'm saying is the k minimum value of k has to be the minimum value of k has to be equal to 6, right? It can be greater than that, but this is the minimum possible value, right? And this is the, we can play on this value of 6, right? That's why what we can do is So if we choose if we choose A dash equal to B dash, and let's say we decided to take it 1, so in that case we will start from 6 itself, right? So that's why what I did was I rounded the the minimum possible value, which, because I want to maximize the range, right? That's why what we did was we took divide by 2 here, right? And we just found the left.
Hello.
Yes.
Why are we maximizing the range here?
Why we are maximizing is we want, like in the worst case scenario, it may happen, like let's say if you have 1 and 4, let's say L is equal to 1 and R is equal to 4. Now what can happen is, in this case, what can happen is, let's say you have 1 by 2. Let's say if you decide to take 1 and 1, in that case also this will become 1, right? 1 by 2. So if you take seal, so you will have 1 only, right? Now, so what I'm saying is, whatever value of k you will take, it will definitely be greater than 1, right? Greater than equal to 1. But let's say if you took a equal to 2, and let's say if you took b equal to 3, in that case what will happen is this L plus 2 plus 3. So now your L will start from a smaller value, right? And you will get less value of k. And if you have less value of k, in that case your the number of values which you can take decreases, right? That's why. Is it clear?
Okay.
So by the way, always we will take the values of A dash and B dash to be 1.
No, what I'm saying is we are finding the minimum, the possible ranges, right? Let me show you the code and explain you one second. What I mean to say is, what I'm saying is, we will always be able to find, like let's say we have 11 and 15. So what I'm saying is, we have what I'm saying is, let's say you have 11 by 2, right? Now 11 by 2 is 5.5, right? So if you do it, then you will have 6 here, right? So what I'm saying is you can start from 6. So the possible value of k can be 6. Similarly, if you do 15, so if you do by 15 by 2, this is equal to 7, right? Like let's say because if it is 7.5, then since this was at the less than equal to part, so we will take it 7, right? So you can take value of k as 6 and 7 both. Similarly, let's say if it was 11 and then 7, because let's say if we took a value of 11 as let's say if we took the value of k as 6, then in that case 6 comma 6, 6 plus 6 equal to 12. It lies in the range of 11 to 15. Similarly, let's say if you took 7, k equal to 7, in that case 7 plus 7 is 14. So yeah, we are taking a equal to 1 and b equal to 1, and we are giving the equal value. The edge case where it will fail is, let's say if you take L equal to 7 and R equal to also 7. So in that case, what will happen is, if we follow this approach, so what will happen is, if you do 7 by 2, you will get 3 plus 1, 4, right? And if you do R by 2, 7 by 2, you will get here 3, right? So this will be 4 and this will be 3. So this won't be giving answer. So for this particular edge case, what we can do is, we can iterate over all the, because we know that L is for this particular case, we need to find an answer, right? So what basically, and we also want to make sure that its GCD should be greater than 1. So for that, what we can do is, we can just iterate. We can find all the factors of this 7, and because k will be factor of this 7, right? Because since L and R both are because what it is saying is a plus b should be greater than equal to R, right? And now if L is equal to R, now your a plus b is fixed, right? Right. And it is equal to L. Now in that case, what we will do is, we will just find a factor. Because a plus b is equal to a dash plus b dash into k, right? So in that case, what we will do is, we will just find a factor of it, and that will be the value of k. for the condition L equal to R, what we are doing. Is it clear?
Yes, yes.
Can you explain the part when L is equal to R?
Okay, when L is equal to R. What I am saying is, let's say L is equal to R. The condition was L, right? Now this was L has to be less than equal to A plus B less than equal to R. Now, what we need to do is, if we are given L equal to R, now this is equal to this guy. Let's say this is 5 and this is also 5. Then A plus B also has to be equal to 5, right? So A plus B should be equal to L equal to R. Now, as we know, A is equal to A dash K and B is equal to B dash K. Now, this has to be equal to R equal to L, right? So from here, we know, right? So this K has to be a factor of L, right? So what we will do is, we will just find any factor of, let's say you have, let's say 77 as the value of L. So K can be equal to, we won't be taking 1 here, right? We just we can find all the divisors in, or you can say all the factors in root n time, right? So in root L time, what we can do is we can find all the factor, right? So we will get 1 as 7, right? So if we take 7, you can take any factor apart from 1 and 77, right? So let's say if you decide to take 7 here, so in that case, what you can do is you can take 1 as 7 and the other can be 70. So in that case, what you will do is you will have this sum equal to 77 and their GCD will be equal to 7, right? So this is what I'm saying. But let's say if you didn't find any, let's say if you have only 7, L equal to R equal to 7. Now in that case, you won't be able to find any factor, right? Because only 1 and 7, because this is a prime number, so 1 and 7 are only, right? And if you take 7, 0, then you won't be able to get the answer. Similarly, if you take 1, then 6, then the GCD will become 1, right? So if you are not able to find any factor apart from 1 and L, in that case we will write -1. Else we will, if we find a factor, so we will write factor comma L minus factor, so that the sum becomes L and GCD becomes equal to factor. This is what I'm saying. Is it clear?
Yes.
Okay. So basically we have solved this part. If L is equal to R, and let's say if L is right, and if L is equal to R, in that case what we did was we just found a factor of it. If we found a factor, then what we can do is we can take it that factor and L minus I factor, so that the sum becomes L. And let's say if we didn't found it, then we just return -1. And in case if we found it, we will continue, right? Because we have already written the answer. In the another case, what we did was we just constructed that range, right? It should be L by 2 and R by 2. We need to find a K which is between L and R by 2, right? Now, if let's say if L is, this case will get already covered in the top part, so we don't need to do this part. You can remove this part if you don't want, right? Because it will automatically be get covered in the top part. So if R is greater than L, what I'm doing is I'm just taking, because we can take any part, so I'm just taking L plus 1 there, right? Because since we have already divided by 2 and divided by 2, so we already have the range, right? It will lie from L by 2 to R by 2, so you can take any value. So I just took L plus 1 there, right? In that range, because I know since R is greater than L, so it will definitely lie there only, right? So that's why.
So here we can take answer as L also now. Right.
Yeah, you can take L also.
Okay.
Is it clear?
Yes, yes. By the way, while contest, I was handling the age cases separately, like 1, 3, and so on. But got new idea.
Like the question of like B and C, like quite difficult to explain sort of questions. Like it does not happen in case of Div 3 that you got such a greedy question, which more sort of a code chef type.
Yeah. Literally, I submitted 6 wrong answers on C, and I was not able to do it.
Okay. From here, I think better questions come. Okay. So you are given three integer n, x, and y. And what they are saying is, let's call
Hello.
the score. Yes.
Bhaiya, can you show the code of when L is equals to R? That case.
Yeah, L equal to R.
Okay, thank you.
So let's say we are given three integers n, x, and y. Now what the question is saying, let's you took up permutation p1 to pn, then the value of the permutation is the score, or the value is the sum of pi, or you can say all the indexes which are divisible by x minus the sum of pi for all the indexes which are divisible by y. What it means is, let me explain you clearly. It means is, let's take n equal to 7, right? And let's say x equal to 2 and y equal to 3. So what the question is saying, the score is equal to, let's say you took a permutation as 1, 2, 3, 4, 5, 6, 7 only, right? The simplest permutation. Let's say you took this permutation. So what it is saying is, it is saying all the indexes which are divisible by 2, you take their sum. They take the sum of their values. So this is index 1, right? This is 2, this is 3, this is 4, this is 5, this is 6, and this is 7 index, right? So which indexes are divisible by 2? This index is divisible by 2, this index is divisible by 2, and this index is divisible by 2, right? So what it is saying, you take the sum of those. So we will take 2 plus 4 plus 6. And what now they are saying is, let's find all the indexes which are divisible by 3, right? So now this index is divisible by 3, and similarly this index is also divisible by 3, right? So they are saying is, take their sum also. So its sum will be 3 plus 6, right? And then this will be the answer. This will be your score, right? And we want to maximize the score, right? Our aim is maximize the score. So yeah, so this is the question. So one thing, okay, so basically, so this was the question. Now you will think that this 6 got repeated here, right? The 6 was coming here also, and this 6 was coming here also, right? Why did it happen? Was because if we see the indexes which are divisible by 2 and 3, so index 2, index 4, and index 6 was divisible, right, by 2. Similarly, indexes 3 and index 6 was divisible by 3, right? So this 6 and this 6 got repeated, right? So let's say if I want to find, first of all, let's see how many indexes are divisible by 2 and how many indexes are divisible by 3. So number of indexes divisible by 2 will be 7 by 2, right? So 3. Similarly, how many indexes are divisible by 3? That will be 7 by 3, floor of that, right? So 3, we found that. And similarly, 2. Now you will say, how many of them are common? How can we find that? So basically what I'm saying is, if you want to find the common part, so let's take the LCM of 2 and 3. If we take the LCM of 2 and 3, we will get 6, right? And so if I do 7 by 6, I will get to know the common part, right? So the so 7 by 6 is 1, right? So that's why this one is common, right? Just a second. So similarly, let's say, so we don't need to find the answer of this common part, right? So what I'm saying is, what we will do is, we will find the index, number of indexes divisible by x. Then we will find number of indexes divisible by y. Then what we will do is, let's say we found the number of indexes divisible by x, we found the number of indexes divisible by y. Then what we will do is, we will remove the common from both, right? Because that will, if you take the common part, it will get subtracted from both the end, right? The 6 was subtracted here also and here also, right? So it does not make any sense to take it, right? So we will remove the number of common indexes from here also and here also. Now you will say, how will find this one? This is actually equal to n by x, right? And this is also equal to n by y. And this common part will be actually equal to n upon LCM x comma y, right? Let's take one more example to get it more clear. So let's say if n is equal to 15. Now let's say if x is equal to, let's say 6, and let's say y is equal to 9, right? Now if you want to find the indexes which are divisible by x, so it will be 6 and 12 only, right? Similarly, the indexes which are divisible by 9 would be, let's extend it to 30, so we will get more values, right? So now if we take 30 by 6 and take a floor of it, so we are getting 5, right? So we will getting 16, 12, 18, 24 and 30, right? Similarly, let's say we have y equal to 9. So if we take 30 by 9 and take a floor of it, so you will be getting 3, right? And we can see that 9, 18 and 27 are the ones, right? Now if we take the LCM of 6 and 9, it will be 18, right? So what are the indexes which are divisible by 18? It's only 18, right? And that's the common part, right? So this was 5, this was 3, and we will remove the common part. So one is removed. So we are left with 4 indexes of this place and 2 indexes of this, right? Now, as in the question, we need to subtract from x those indexes which were divisible by x, and these were the one which were divisible by y after removing the common part, right? Because we are removing this common part, so 6 and 6. Now we want to maximize this sum, this overall sum. So if we want to maximize the overall sum, what we will want to maximize is, we will want to maximize this positive part, right? And we will want to minimize this negative part, right? Right. So, and you have a permutation, you need to arrange it in such a manner that you need to arrange those elements in such a manner that the, what you can say, the difference is maximum, right? So we decided that, okay, we will since this is the positive part, x, all that those indexes which are belonging to x will give us a positive answer, and the sum of all those which belong to the y1 will give us the negative value, right? Because a minus sign is, right? So we want to give as large as possible values to all the indexes which are divisible by x, and we want to give as minimum as possible values to all the indexes which are divisible by y, right? So let's say if n is equal to 7, x is equal to 2, and y is equal to 3, right? So now in that case, what we need to do is, so this is 1, this is 2, this is 3, this is 4, 5, 6, 7. Now this index and this index is divisible by 2. This index is divisible by 3. We are not taking the common part, right? Because it will be get subtracted from both the sides, right? So what we want to give this place and this place the maximum value, and this place the minimum value, right? So how can we do that? So one way to find to do that could be, since we have the permutation, right? So we have the value from 1 to 7, right? So we want to give the maximum value, right? So what we will do is, we will give 7 and 6 here, right? And we want to give this place the minimum value, right? So we'll give 1 here, right? So basically what I am saying is, let's say alpha is the number of indexes divisible by x, right? Minus common. Similarly, beta be the number of indexes divisible by y minus common, right? So what I am saying is, we will let's say if your alpha is equal to 5, and let's say if n is equal to, let's say 15, so we will give 15, 14, 13, 12 and 11 to these indexes. And let's say if your beta is, let's say your beta is equal to 3, so we will give 1 2, 3 to those beta indexes. This is basically what the logic part is. Is this much clear to all?
And therefore, the common part can be anything, right?
What because
Common
what will
part?
happen with the common part is it will be included here also and included here also, right? So it will get cancelled, right? So why do we care for it?
Yes.
Are you getting the point? That's why what I'm saying is let it be anything, because whatever what will contribute to the answer will be the non-common parts only, right? And not the common part, right? It will get some value, we don't care, right? Because we just have to worry about those indexes which are divisible by x, divisible by y, right? And from that also we need to remove the common part, right? Because it will be there on both the sides, right? So you take it or don't take it, does not matter, right? Because its contribution will be 0, right? And you understood, right? Those which are divisible by x, we need to maximize those values, and we will put the maximum elements there, and those indexes which are not which are divisible by will give the minimum value, right? So that we can maximize a minus b, or you can say this this part, this score value. Is this clear to all?
Yes.
Okay. So now how we will solve it, this is, so let's see this part. So if we had value of alpha equal to 5 and n equal to 15, so we took 15, 14, 13, 12, 11, right? So if we want to find the sum of this, what we can do is, we know that 11, 12, 13, 14, 15, some sort of summation formula, right? Number of elements is actually equal to alpha. So what will be its sum, right? If you take this as AP also, so the summation of AP, if I directly write the summation of AP, so it's actually number of elements into first element plus last element, right? This is number of elements whole divided by 2. So this will be equal to alpha. Sorry. So this will be actually be equal to alpha into 11 plus 15 by 2, right? Similarly, the sum of these will actually directly beta into beta plus 1 by 2, right? Directly. Is this clear to all?
Yes.
And this first element, this 11, what will this 11 actually be? This will be actually n minus x plus 1, right? Because we want not x, this will be alpha, right? Because if alpha is equal to 15, so this is, if this is 11, so you can say, right, 15 minus 5 plus 1 is equal to 11, right? So we just need to take the difference of this formula and this formula, just that, and that would be our answer. Is this clear to all?
This problem was easier than the past two problems, right?
Yeah, I also feel that, right? Oh, so basically what we did was, we took the seal of it, this part, and we took we found the number of divisors divisible by x, then we found the number of indexes divisible by y. In order to find the common part, we first found the LCM, and we know that the LCM is actually because we know that LCM into GCD is equal to product the numbers, right? So in order to find the LCM, what we do, we will find product divided by GCD, right? And then now the number of common divisors is n by LCM, right? Then we will just remove those all common part from x also and y also, then just apply that formula. Because if you will see that this is here, it is written div of x, this was alpha into 2n. Why it is 2n minus div x? It was because as I told you, this was alpha by 2 into first plus last, right? We know that last is n, and this is n minus alpha plus 1, right? So this becomes 2n minus alpha plus 1 into alpha by 2, right? So this is actually what is written. Div x into alpha into 2 into n minus alpha plus 1 divided by 2. And this is why I have written this is n into n plus 1 by 2, you can say, right? Or beta into beta plus 1 by 2. We have just taken the difference of it, and that's the answer, simply. Is it clear to all? Okay, I will take it as a yes. So now let's go to the E question then. So basically what the question is saying is you are given an array of size n, and the elements will be a1 to a2 up to an, and you are also given a binary string consisting of n characters, right? Binary string is 0 1, right? Now what they are saying is they will be giving query of two types. One will be one LR, where they will be giving us the range L to R, and what they are saying is you need to flip all the indexes, right? So if something was if s of I was equal to 0, then make it 1, and if it was 1, then make it 0. And in the second type of query, what they are saying is you need to find the bitwise OR of let's say we have like let's say first index, third index, and fifth index have value 0. S of 0, let's say s of 1 is 0, s of 3 is 0, s of 5 is 0. So if they have given g equal to 0, so what they are saying is then you will need to find the GCD of A1, A3, and A5. So basically what they are saying is all the indexes such that if S of I is equal to G, you need to find the bitwise OR of all those indexes. Basically, this is what it is saying. So is the question clear to all? Then we can proceed with the solution part.
Yes.
Hello?
Yes.
Okay. So if we go to the solution part, let's take let's think of how can let's if we think about the brute force solution.
सेकंड वन फिर से
So
बताइए
basically what
हेलो
okay,
सेकंड वन फिर से बताइए सेकंड वन
मेरी मेरी आवाज आ रही है, राइट?
यस यस सेकंड वन
Yeah.
फिर से बताइए ना
Okay, I
Condition.
will explain it. Okay. So let's say if your string was 10001, right? And your array is let's say 2, 3, 5, 7, 9, 8. This is 8. So what the question is saying, so they will give the query of this type. So let's say if the value of g is 1, in that case, all those indexes corresponding to one value, you need to take GCD. So you will take GCD of 2, 5, and 8, and you will return this value, right? Because this index, this let's say this is 1, 2, 2, 3, 4, 5, and 6. So this first index, third index, sixth index, right? These all index corresponds to value 1, right? So you need to take the GCD of 2, 5, and 8. Let's say if the value was of g was equal to 0. So now this index, and this index is value 0, right? So you need to take the GCD of all those indexes, the corresponding elements in the array of all those indexes where it had value equal to 1. Which index has value of 1 equal to 1? Second index, fourth index, sorry, value equal to 0, second index, fourth index, and fifth index, right? So the corresponding value, A of 2, A of 4, and A of 5. We need to take the XOR of it and we need to return. Is it clear now?
यस यस
Okay. So now what we need to do is, okay, so the question is clear. So if we go by the brute force approach, so what you will do is, if you will be given a query of L from R, so what you will do is you will just run a for loop, and just by brute force, what you will do is you will just flip those indexes, and if when we will be given, let's say g equal to 1 type of query, then you will just again iterate over all those elements and will find all those indexes where S of F1 is, and you will take XOR of those
Your
indexes. Right?
voice is
But this
cracking.
will be of Q into N complex. Is it clear now?
Yes, yes.
Okay. So basically, what I'm saying is, so in that case, by if you do brute force, then it will take Q into N complexity, right? And we want to optimize it. So basically, the question is how we will do it. So basically, what I'm saying is, let's say if we didn't had any query of type L comma R1, right? So in that case, what we actually need to return. So let's say if you have 1 0 1 1 0 1 0 1, right? And let's say if they give G equal to 1, we need to return the XOR of this index, these elements, right? And let's say if they give G equal to 0, then we need to return the XOR of values corresponding to these indexes, right? Now, what I'm saying is, so if we don't have this type of query, so what we can do is, if we want to optimize our solution, what we can do is we can find XOR of 1, all those indexes which have 1. So this one, this one, this one, this one, and this one. By XOR, I mean the corresponding elements in the array. So let's take some elements also. So 2, 3, let's take 4, 5, 6, 7, 8, 9. Let's say the array corresponding array elements are 2, 3, 4, 5, 6, 7, 8, 9, right? So XOR of 1 will then be 2, XOR 4, XOR 5, XOR 7, XOR 9, right? Similarly, XOR of 0 will be 3, XOR 6, XOR 8, right? Now this will be XOR 0, right? And so if they give G equal to 1, we can return this as answer. And if they give G equal to 0, then we can return this as answer, right? But where is the issue? The issue arrives where when they will say us to flip the bits, right? So let's say initially we computed that XOR is 1 and XOR 0, which corresponds to XOR of these elements, and then 0, 1 corresponds to XOR of these particular elements, right? Now let's say they decided to flip these 4 indexes, right? They give L equal to this, they give L equal to this index and R equal to this index, and they ask us to flip those. Now what we will do is, okay, so okay, and so we
You can
decided to
use
flip this.
prefix.
Okay, you can.
We-
Yeah, we will. Yes.
Yeah.
Continue, please. I'm audible to all, right?
Yes.
Okay, so we will come to that fix or not. So what I'm saying is, so now the question is, they will say to flip those, right? And if they will flip this one, so now this will become 1 0, right? And now if they give a query of G equal to 0 type, now in that case, what will happen is, so we need to return actually XOR of 0, right? Part, right? But that XOR of 0 actually right now has these 3 indexes, right? But after that L to R query, it has now, it should return these indexes, right? These new indexes, right? So what I am saying is, so we need to remove from this XOR 0, we need to remove the contribution of this old one, and we need to add the contribution of these new one, right? So, okay. Now, if we go for the removal part, let's say, I am saying is, let's say the XOR of this part is alpha, and XOR of these 3 indexes, this one is beta, right? So, if we want to remove this from the 0 part, because this 0 will get converted to 1, and these all 3 1 will convert it to 0, right? So from XOR 0, we need to remove the XOR of this 0, and we need to take add this XOR part, right? So for that, okay, and let's write here once again, 1101 was there. Now what I'm saying is, the XOR 0 which you were having, since it was having the contribution of this part, right? But when you will flip it, this will become 0010, right? So we need to find a way to remove this contribution and add this contribution, right? This three contribution. So let's say the XOR of this part is alpha, and the XOR of these three is beta corresponding, right? The corresponding XOR is beta. Then if I want to remove this part XOR, what I will do is I will XOR alpha, right? So it will get removed automatically, right? Because this already has alpha something, like let's say k is or alpha, because it had contribution of alpha, right? And if you do it again by alpha, then this alpha and this alpha get cancelled and we get only k, right? So that's why if I want to remove also, then I will take a XOR with alpha only, right? Similarly, I want to add the contribution of these elements, right? So for that also, I need to take a XOR with that only, right? Beta. So what I am saying is, if you want to find the new value of XOR 1 or XOR 0, you basically need to take the XOR with alpha and beta. This will act as a removing part also. So I told you about XOR 0, right? Similarly for XOR 1, initially it had the contribution of this one and this one, right? And you need to remove this contribution, right? And we know that its XOR is beta. So in order to remove, you will take XOR with beta. And now you want to add this contribution. So in order to get it, you will take it with XOR. So if you see what you are actually doing here and here is you are actually, what you are doing is XOR 1 is also taking XOR with alpha, beta, and XOR 0 is also taking XOR with alpha, beta only, right? Which is what? This is actually XOR of L2R, right? Similarly, this is also what? XOR of L2R. So what I am saying is, let's just pre-compute XOR of 1, XOR of 0. And if you get a query of type L2R, now in order to update this XOR 1, just directly take it, take the XOR, take a XOR of it with alpha comma beta or XOR of L2R. Similarly, in order to update XOR 0, you can just take a XOR of it with XOR of L2R. Now you will say that how we will be, because now if you go to find XOR of L2R, can take O of n, right? So what we can do is, if we want to know it quickly, we can do a pre-computation part, right? So if you want to know the XOR of L2R, what we can do is, if you have already pre-computed it, so this will actually be equal to 3 XOR of R XOR 3 XOR of L minus 1, right? So if you do that, you will can get XOR of L to R, right? And for each query of type L 1 comma L comma R, you just need to update XOR of 0 with XOR of L to R. Similarly, do it for 1 also. XOR of L to R. And let's say then if they give us g equal to 1, then we already know the value of XOR of 1. So we will directly return it. If they give z equal to 0, then we will return XOR of 0. Is this approach clear to all? Hello? Okay. So if we go to the code part, just a second. Okay, so we go to the code part. What I have done already is I took a XOR already so that we can use it later in order to get XOR of L2R quickly or optimally. Similarly, I have taken XOR of 0 and XOR of 1 as 0 in the initial part, and I am initially updating XOR 0 and XOR 1. If SFI is equal to 0, then it contributes to XOR 0, and if it is equal to 1, it contributes to XOR 1, right? And as I told you, so if we are getting L and R, so what we are doing is we are updating XOR 1 with the XOR of L2R. Similarly, we are updating XOR 0 with the XOR of L2R, right? This is what we are actually doing. And if we get 0 is equal to 0, so we are returning XOR 0. And if we are getting XOR equal to 1, we are returning 0. Is this clear to all? Once again, okay. Dhisraj, can you unmute and just ask me what which part you have the doubt?
Actually, my internet was gone.
Okay, so what part do you have the issue? I can explain that specific part.
Code, just the code.
Okay.
I got the implementation.
Okay, so the code part, what we basically did was, so the code part or the implementation part basically has two parts, right? We first need to optimally find the XOR between L to R, right? So now in order to do that, what we do is we will find a pre-XOR, right? So that if you want a XOR from L to R, what you can do is just take pre-XOR of R, take a XOR with pre-XOR of L minus 1, so that you can get a pre-XOR of L to R, right? So for doing that, we are just storing this XOR part, right? Now we have done the pre-computation part, and we are finding the XOR of 0 here and XOR of 1 here, right? Just we found the XOR of 0, XOR of 1 here, so that this is the initial value of XOR 0 and XOR of 1. All those corresponding indexes which have 0 will contribute to XOR 0, and all those indexes which have XOR 1 will contribute to XOR 1 part, right? Now basically what I'm saying is, so if you have if you take L comma R, now if you have the query of type L comma R part, now in that case, as I told you in the implementation part, we will just update XOR 1 and XOR 0 with the XOR of L2R. We are first finding XOR L2R, and just we are updating XOR 1 and XOR 0. And if the question asks a query of type 2, in which it is saying that file all the XOR of all those indexes which corresponds to 0, we will directly return XOR 0 and XOR 1, right? As we have already have the value in the coding part, the small part. Is it clear? Okay. So let's go to the last question now. So here, what the question is saying, I will. You are given n animals. Now for every element, they have given a element of which a particular element is afraid of. Let's say they have given, let's say 2 is afraid of 4, 5 is afraid of 7, something like that. So they have given us a list like the animal of which every element is afraid of, right? Now what they are saying is, uh, if you now you need to sell all those n elements, right? All those n animals, right? So they are saying is, let's say if you decided to sell AI element, here what it is saying is the ith element is afraid of AI element, right? The ith element, so first index is afraid of A1, second element is afraid of A2, third element is afraid of A3. And they have also given us the cost, right? The first element cost is C1, second element cost is C2, third element cost is C3. So they have also given us the cost, right? Now what the question is saying is, let's say if you sell AI element before I, or you can say, since ith element is afraid of AI, right? So if you sell AI before I, you will get CI coins. But let's say if you sell I before AI, right? Or you can say while selling I, if AI is already present, right? If it has not been sold yet, so you will get double points. So basically, the question is saying that. Now the question is saying you need to find an arrangement such that you can maximize the total coins earned. So we need to find the maximum value. So let's go to the logic part, and I will try to explain the question more. So what it is saying is, let's say the element 1 is afraid of element 2, right? And let's say the element 2 is afraid of element 3. And let's say the element 3 is afraid of element 4. And let's say the element 4 is afraid of element 2. So basically what the question is saying, if I sell, let's say if I sell this 2 first, let's also give some cost here also, right? So let's say this is 2 cost, this is 4 cost, this is 6 cost, and let's say this is 5 cost. So what they are saying is, let's say if you sell this 2 first, right? If you decided to sell this 2 first, so if I decided to sell 2, so since 2 is afraid of 3, right? And if I decided to sell 2 first, and since 2 is afraid of 3, and since 3 is not have been sold yet, so I will get twice of CI. So I will get 8 points, right? And let's say after that, if I decide to sell 1, but since 1 was afraid of 2 and it was already sold, I will get a value of 2, right? But since I want to maximize my points I am earning, I want to find a way, right? Because I'm getting extra points when those elements which are afraid of me are being sold in the later part, right? For example, if I would have chosen first 1, then if I would have chosen 2, in that case, what will happen is, for 1 also I will be getting 4, and for 2 also I will be getting 8, right? Because when I'm selling 1, it is afraid of 2, right? So it is not being sold, so I will get 5. Similarly, when I'm selling 2, 3 has not been sold, right? So I will getting twice. So in that case, I will be getting 12, right? But if I had sold first 2 and then 1, in that case, I would have got 4 plus 2 only, right? So you see a particular something, right? So we need to find such arrangement, and we know that if we want to get twice points, we need to find a particular order in which we need to make sure that those whom I'm afraid are sold after me, right? So this thing looks like some sort of dependency thing, right? That my on which whom I depend should be solved after me, right? So from here I got the feeling of topological fault. There is some sort of dependency, right? First of all, whenever we have a type of graph in which every element points to exactly one element, in that case what happens is, it because each element is pointing to every other element, so in that case what happens usually is uh, we get a graph which eventually ends into a cycle. So you will, like, let's say for example this, we take this example only. So here you can see 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, and 4 is pointing back. Since it was given that AI won't be equal to I, so you won't be getting a one length cycle, right? So what will the question eventually end up is, or you can say the graph will end up would be some sort of this thing only, because every element is pointing to someone, so it will end up like that only, right? It will end up, it may be possible that this graph only have cycle only, right? Because every element is pointing to someone, right? So it may be possible that you have this sort of graph. So we can say this is the cyclic part, and this is the non-cyclic part, right? So we will be having a graph of this part and this sort of graph, right? So let's take one more graph again. So let's say we have a graph of like this type. So here what it's saying is 1 is afraid of 2, 2 is afraid of 3, 3 is afraid of 4, 4 is afraid of 5, and 5 is afraid of 2. Similarly, let's say we have another person, 6, who is afraid of 2. Similarly, we have 7, which is afraid of 1, right? Now, as I told you, we want to take first those we need we want to make sure that we find the maximum price, right? So let's give them a coin. So let's say this is 2, 4, 5, 6, 7, let's say 3 and 4. These are the coins distribution, right? So I want to select in such a order that of those I am afraid of will get selected at the end, right? So you can see that for this non-cyclic part, let's say we have some or like 7 also here, right? For the non-cyclic part, what we can do is we can find it in the topological sorted manner, right? Or what I mean to say is, since this we can start from this 7, then we can move to 1. Similarly, this was 7, right? And let's say this is 8 then. So what we can do is we can start from the 7. If you start from the 7, then since 7 depends on 1, right, and it has already not yet taken, so I will get 2 into 4 points. Then if I go to 1, if I go to this place, since it depends on 2 and it has not yet been taken, so we will be getting 2 into 4 there also, or you can say 4 into 2, right? Let's say. Similarly, if we take 8, in that case, what I will, since 6 is not yet been taken, so we will be getting, and let's say its cost is 11. So we will be getting 11 into 2 points. Similarly, after that, if we take 6, then since 2 is not been taken, so we will be getting 5 into 2 points, right? We will be getting 5 into 2 points. So this is what we will do for the non-cyclic part, right? After so here we have actually maximized out, right? In the non-cyclic part, we have got all 2 into Ci, 2 into Ci, 2 into Ci, 2 into. This was the maximum possible, right? So if we do in that topological sorted manner for the non-cyclic part, then we will be getting the maximum possible answer, right? After doing this, what we will be left with? We will be left with the cyclic part only, right? This sort of cyclic part, right? Now, since we are left with so if we are left with the cyclic part, now we know. Let's say if I start with 2, if I start with this 2, so if I start with this 2, then I know that this 2 depends on 3, so we will be getting 2 into 6 completely. And let's say if I then go to 3, let's say I've done this, and if I go to 3, then now I know that 3 depends on 4, so we will be getting 2 into 3 here also. We will be getting twice point also. And let's say if after that I go to 4, and I know that this 4 depends on 5, so we will be getting again 2 into 4 points, because 5 is not yet visited. But now if I go to 5, I know that since I have taken all the 3 remaining, I need to take only 1 into 7 only, right? I can't get 2 into 7, right? So in a case of cycle, you can get 2 into everything except one element, right? Except this element. So if we want to maximize our value, what we can do is, we can, what I'm saying is, so if you have a cycle, in that case, you can get 2 into 6 plus 2 into 3 plus 2 into 4. But one of them has to take 1 into 7. Right? One has to take 1. So who will it be? It will have to be the minimum element, right? If you take the minimum element, in that case, we will have the maximum value, right? So what I'm saying is, what you can say is, I'm saying is, so since among all these 4, this guy has the minimum value, right? So I'm saying is, let's start with 4. So if I start with 4, let's draw it again. 2, 3, 4, 5, and 2. This had 6 value, it had 3 value, it had 4 value, it had 7 value. So I'm saying is, let's start with this 4. If you start with this 4, in that case, you will have 2 into 4, because this 5 was not visited. Similarly, when you will go to this 5, you will get 2 into 7 here. When you will go to this 2, you will get 2 into 6, and then at the end, 1 into 3. This is the main logic which we want to do. So the question can be divided into 2 parts. First, for the non-cyclic part, we can apply topological sorting and do into the sum of those. And then for the cycle part, what you can do is, you can find the sum of the complete cycle sum of complete cycle into 2 minus minimum element of the cycle. Right. Here what we did was, if you do 2 into 3, then you need to minus subtract 3, right? So this is actually equal to 2 into sum minus minimum element, right? For the non-cyclic part. Is the approach clear to all? Hello, is the approach clear?
Yes.
Okay. You understood the part, right? First we are solving a non-cyclic part and then for a cyclic part, and why we got this formula sum of complete cycle into 2 minus minimum element, right? Because we need to sacrifice on one particular element, right? And since we need to sacrifice on one, why we should always take the minimum part, right? Now the code part, right? If we go to the coding part, so if we go to the F1, so first, as I told you, we will go with the topological sorting part, and we will just remove all those part which was a non-cyclic part, right? So for doing that, I'm just when I'm taking the input, I'm also calculating the image of each element, and then I'm just pushing all those elements which have image equal to 0, and I'm also pushing it inside my answer array. All those. This is just typical topological sort code. Just a second. Where I was. Yeah. So this whole part is just a typical topological sort code only, right? And what I'm doing is I'm just visiting an element, and I'm just decreasing the image of its parent. And if the parent's image becomes equal to 0, then I'm again pushing it, and I'm also appending it to my answer. This is what I'm actually doing. So once we are done with the and I'm also marking it as visited, so that at the end we know all those which are part of the cycle, right? Now, okay, so if we have done till this part, then we know that what would be the answer for the we would have known the answer for the non-cyclic part. Now for the cyclic part, what we need to find is we need to find the sum of the array, and or you can say sum of the cycle and the minimum element, right? We need to find that from those two, right? So in order to do that, what I did was I just called the DFS, right? Just called the DFS, and right, and what this and actually in this question it just asks us for the order, right? So it does not ask for the value, right? So if we talk about the order, so in that case, let's say if this was a cycle, so in that case we know that if we know the complete cycle, so we know the pattern of the cycle is first 3, after that 4, then 5, then 2, then again 3, right? So what I am doing is I am finding the element which has the minimum value. So by doing DFS, I will be able to find this 3 as the minimum value, right? So what I am saying is we will start after 3. So we will start with 4, then 5, then 2, and at the end we will do it for 3. Right? Because we want that the 3 should come at the end, right? The person with the minimum value should come at the end. So I'm just finding that order, right? So first what I'm doing is I'm just finding the orders of the cycle by using DFS, right? Using DFS, I have taken an empty vector order, and I'm just storing the elements in that order, right? I'm just pushing those elements, and simultaneously I'm just finding the minimum element also, right? If I've taken a mini, and if the CI is less than equal to mini, I'm just updating it, right? I'm just finding the element which is minimum, and simultaneously I'm just storing the elements of the cycle in order. So if I have the minimum element and the elements of the cycle in the order, so as I told you, I have to make sure that I visit the element with the minimum value at the end, right? So for that, what I'm doing is ID is the index. ID is the index which is the minimum element, right? So I'm starting after it and then before it, and at the end I am inserting the minimum element. So what I mean is, because the DFS could have started from any point, right? What I mean is, you have, let's say, 2, 3, 4, and 5. So you may get order S2, 3, 4, 5, right? Or your DFS order could also have been 3, 4, 5, 2, right? But we know that since the minimum element is at 3, so one particular order, and we want that this should come at the end, right? This should come at the end, right? For that, what you can do is first we will write these elements 4, 5. Let's say this is ID, then ID plus 1, ID plus 2. Then we will start from 0 and we will take 2, and at the end we will just insert 3. So I have done the same actually here also. What I am saying is, first we will iterate over all those last elements, then we will do the starting element, and then at the end we will just insert index. That's it. Is it clear to all? Okay. I guess the approach is clear to all, right? So everyone, please fill the feedback form available in the chat box or in the comment section, and we will end the session.